Hello again, everyone, and welcome to session 10 of HP's Beyond the Forge, a Metals 3D printing series. My name is Zach with HP 3D Print Marketing, and I'll be your host. This series consists of short 30-minute webinars providing the main information you need to understand 3D printing with the HP MetalJet and its benefits. The topic for this month's session is MetalJet for machine shops and service bureaus, presented by Harish Irinki, Senior Application Engineer and Strategic Account Manager. As a reminder, we have the Q&A option at the bottom, so you can submit your questions and we'll try to answer them during the presentation, or we'll reach out afterwards. Now, I'll turn it over to Harish to get us started. Go ahead, Harish.
Hi, everyone. Thank you for taking time this morning, this afternoon, wherever you're in this part of the globe. Thanks for taking time out of your valuable schedule to attend this webinar. And thank you, Zach, for the introduction. Today, I'll be mostly in the next 20-25 minutes. I will be covering various aspects of why MetalJet S100 solution it can address some of your needs. How can it complement your existing business? Either it could be a service bureau or it could be a machine shop. You may already have a familiarity with 3D printing in terms of plastics and serving your customers, or it could be a CNC shop and you're trying to expand into other manufacturing technologies. I will be at high level. I'll be going through what are the typical market challenges and opportunities we've been seeing by talking with various OEMs. Right now, we have existing contract manufacturers who are using a S100 solution to serve these needs of various customers. Where are they finding the opportunities? And if you find such opportunities in your business, I think you're ready to bring in the technology. Then it goes back to why are MetalJet? Why not XYZ technology can help with in addressing those needs. I'll briefly talk about MetalJet capabilities, and finally, I picked out few customer success stories to help to explain this story. But there are many such application customer success stories that we can talk about if the time permits, or you guys can reach out to us anytime after the webinar and we can go through them in detail. So I wouldn't spend much time in general on this slide because many of you, I'm sure, is familiar with HP brand name. But one thing I would like to focus here is what makes us different from every other 3D printing company that exists today is in any product we built, ranging from a small home 2D printer all the way to a big, large format printer that is printing all the ads that comes on your TV boxes and stuff. The core of the product, the heart of the product is the same. That is HP's innovation. What it is three. One is printheads. HP owns the IP. We made the printheads. Right now we are on Gen 5 that can do 1 billion drops per second. Then the second is binder, which is compatible with various materials. Either it can be a paper, it could be a polymer powder, or it could be a metal powder, the binder. The third is how do you integrate these two to generate a good quality product? Either it could be a printing letters on a paper using some black ink or colored ink, or printing and making a three-dimensional part. So we are evolving from 2D to 3D. So it makes very good organic sense why HP has invested in 3D. With that, we have launched our polymer series machine, which is multi-jet fusion, we call it as, in 2017, followed by MetalJet announcement a year later, where we launched our alpha program with well-known names in the field in powder metallurgy and metal injection molding, GKN and Parmetic. And since then, we've been refining the alpha program, and we launched our production printer in 2022 with the production applications with Schneider Electric and John Deere. How our contract manufacturers are using our technology to serve their needs. Today, we are expanding our contract manufacturing base with Indomim and Endeavor 3D, our recent players who acquired our printers. And right now, we are making several thousands of parts within this each contract manufacturers. They're using different materials, and they're addressing the needs of the customer depending on their within the constraints they have. So this is our new next gen metal jet solution. As you can see, if you have visited one of the booths, you might have seen the physical product, or you might have seen a video of how the product works. Or if not, we have like Zach said, this is a beyond the webinar series, beyond the Forge webinar series, and you would be able to go to HP's website and see the printer in action, or video of the printer, how it works and stuff. To give you a very quick 15 seconds overview of what is our product is from left to right. The left is a powder management station where y- you can insert a build unit. Imagine build unit, if you're a big Star Wars form like R2D2 robot, it can move from one station to other station. If you're familiar with multi-jet fusion, which is our plastic 3D printing process, you must be familiar with our build unit. So what this powder management station does is it fills the powder depending on how tall the build you want to be. Once it's done, automatically it fills it. You take it out, insert it in the printer, which is at the center part. You print the part by layer upon layer, depositing the ink in the required regions. Basically, what you're trying to do is you have metal powders which are in spherical in shape, sub 22 microns. You're applying a glue in selected regions and gluing them together to form a three-dimensional shape. So once this glue is formed, the metal is still a powder. It's not melted, it didn't become strong. So what you do is, but still it has loose powder where there's no binder. So you put it in this third step where you put it in a depowdering station, where you separate this part, which has a glued metal powders together, and loose powder goes back to powder management station, recycle and use it. So nearly 99% of the powder we reclaim. You can use it for printing the next set of parts. There is not much wastage. Once you take this part which has gluing metal powders together, you put it in a high temperature industrial oven. It doesn't need to be a specific branded oven. It can be anything for that material. And once you take it to close to melting point and cools down, you end up with a solid metal part, which is similar to what you see in the field. If you're a CNC machine shop, it could be similar to your bar stock. If you're familiar with investment casting and metal injection molding, it's similar to what you see in the field. So with that, okay, great. You guys can ask me like, hey, this is great. There's a solution. It's good, automated. But why? Why should we acquire the solution? What is the advantage to our business? So, not going much into details, the world has changed post-COVID, the supply chain, you guys might be hearing from various people. If you go to a military or army session, and they will be talking about how the supply chains are affecting Department of Defense in US. If you go to a 3D printing show, people will talk about how the supply chains are affecting investment casting. If you go to powder metallurgy, they will talk about how supply chains are affecting metal injection molding and injection molding thing. There are many reasons for that, but the thing is, people are looking for a solution to their needs. The investment casting foundries are in the declining path, especially in the US. So people are looking for alternatives. Where can I make this 200 parts? Right now, the foundry is not able to take my business because 200 parts of this design may not be a perfect solution for them. Or what about my 5,000 parts, which are similar to metal injection molding, and it's too expensive if I tool it up and make it, and not many MIM providers would like to do that. Or it is a complicated design that MIM solution requires multiple sliders, multiple toolings. The tooling investment goes high. How can I get it? How can I get it done? I think this is where the OEMs are trying to figure out the alternate solution, and there are several ways to do it, right? And why is it causing, right? There is a lead time, there's supply chain, there's a dependency of skilled labor, and skilled labor is going down, and right, and there are several sustainability and economical impacts as well causing this. And we believe additive manufacturing in general, not just specifically metal jet, has can make this happen. But now the real problem is, how can you make this happen without compromising on the design, without compromising on material properties, without compromising much on economics? You cannot say, hey, it's a 200 parts your customer requires, but you cannot charge them 10 times more because that is not sustainable too. You may get first order business, but it may not help. the main theme is how do we help all these analog technologies be a complement to these analog technologies, and give them the added benefits of enabling them new geometries, parts consolidation, enabling high mix low volume. Okay, you may have 200 pieces per SKU, but if you have 1,000 SKUs, that's 20,000, and there's no need to make tooling for that. The technology can do, and enabling new sizes and obviously turnaround times, lead times, solving that high lead times which they are facing with the traditional manufacturing today. So now, like I said, right, all additive manufacturing techniques are set up to do it, but what makes metal jet the different? Right? Why do you need to think or consider metal jet when you're trying to expand into a metal 3D printing program? Is basically over traditional metal designs, enabling innovative new designs. Let's say you have a very thick part, you can lattice it out. Or if you have two different geometries today, they're making it up because they don't know how to make a tool for consolidated part. But this is a toolless manufacturing. You can do that. While you're doing it, you can improve the customer economics. In general, one example before I know we have a section on the customer use stories, but I will talk about it. Right, investment casting parts today. We have a contract manufacturers across the globe are serving the needs of investment casting parts without changing the design. Because the reason why we can do that is we deposit less than 1% binder in this big, thick, massive 3 kilos, 5 kilos parts, massive parts. That means the more binder you put, you need to take it out. That's a junk in, right? So if you need to take it out, it becomes very difficult with this thick and massive geometry. Since we are putting very less binder and our binder can be completely burned out, we can enable that for the customers without even significantly changing the design, innovating new design, but serving them the same design that they would get out of any traditional manufacturing per se, right? Um, then what is our binder jetting advantage? Then you may talk about, hey, lasers are doing it today. Lasers are more qualified. They've been in the space for a long time, and people in the defense, army, various oil and gas, medical. Everyone is using the thing, right? So I would say the biggest advantage of binder jetting is we have 10x productivity. We the speed of the binder jetting process or metal jet process today is 2000 cc's per hour, right? And you're printing layer by layer. You're making and the properties you're getting versus laser is isotropic properties. So that means the XYZ are nearly identical, right? And you don't, when you're printing, you don't need to use supports. Yes, there are supports needed in sintering when you're sintering the part, but generally you don't need printing supports. Then we are leveraging the existing powder industry powders. So we are not making a specific powder cut. Oh, you need to use only this specific cut, 15 to 45 microns or 60 to 120 microns powder size to use it on our printers. That's not the case. We are using the industry standard metal injection molded powders, which are at high volume already, which are cheaper than existing laser powder bed fusion powders. That's how we are enabling the customers to meet the economics targets from their customers. And then, okay, what makes your binder jetting unique versus other binder jetting companies? I think I went through this initially slides. A printed advantage. We have a thermal inkjet printheads. We are not borrowing the technology. HP owns the technology from 2D printing. We're just leveraging the printing. And the same thing as binder advantage, we have a latex binder, which is a clean burnout, doesn't leave any carbon residue. If you leave any carbon residue in the metal part, it will have a significant effect on your final part properties. That is where we create different. And we know how to integrate this printers and binders. That's one simple example is if you are printing on a piece of paper at a home on a HP printer, human eye is very, very sensitive if there are any discrepancies on the letter printing. You can see, right, when you're printing on a piece of paper, it's perfect. Like it deposits the ink at a very, very precise location. And similarly on metal parts as well, if you're depositing ink in a different locations, it will cause effects on part quality. So since we know how to integrate the printed and binder and how to deposit the ink, That is where we can make the difference. The second thing is operational equipment efficiency or overall equipment efficiency. Today, this is from our install base. This is not HP made the numbers. This is what we have collected over the time with our install base when they're printing. Our printers has an ability to go to 85% OEE. What that means is, right, it is on par with metal injection molding and better than investment casting in terms of OEE. So the printers are running with a less downtime. So for the capex you made and as an investment, they're generating more income out of it. Now you can say that, hey, I'm a small prototype shop. I need to do this, but again, like I said, this is not toolless manufacturing. You just need a digital file. You can do high mix, low volume. You don't need to print the same part over the time and time. You can just pack the bill bed with the different parts and constantly print it. And our printers is such a modular system, which I'll talk a little bit about. You don't need to invest in multiple printers. You just need to invest in the equipment that goes into the printer. Then the other important thing on is an open system material development. We have different categories of material development things available: HP compatible, HP qualified, and HP certified. And if you're not familiar with these words, please watch our webinar series on materials. We have gone through each thing in detail. Just to certify HP certified is HP has done several builds, several thousands of builds. So we know when you put this powder, what it will have an effect on the printer, right? HP qualified is we have a very stringent requirements, stringent protocols, and this Indomim and Sandvik went through the stringent requirements to qualify our powder, their powder on our printer. HP compatible is we tried printing on them, but they didn't go through that stringent quality requirements. But still, they're compatible. Our binder works with them. If there is any need from these core applications, we pull those materials from left to right. Then the other point is a cost. This is always a constant barrier for adoption we see in the field. We had done a very detailed webinar on the cost of the process. I'll just go through high level. It all depends on the volume. If you ask me, hey, can you make this MIM design, which is 50 grams part, 100,000 parts, can it be cheaper than MIM? Not today. MIM is still the best technology out there for that kind of thing. But if you say, hey, this is a complex lattice part, it has a design and MIM tooling is very, very difficult or impossible. Can you make 100,000? Yes, we can do that because that's our bread and butter with our technology. On the same lines, hey, this is a MIM design. Can you make 5,000 parts out of it? Yes, we can do it. Can you be cheaper than MIM? Maybe, but we will be comparable to MIM cost there because the tooling amortization over 5,000 parts is high compared to tooling amortization over 100,000 parts is way, way low. Then the last important question is, oh, you meant it, this made this technology for mass production. Only people with huge bucks can buy this. Not really. You don't need to get the powder management station and powder removal station. Only if you have a demand for like making million parts and like this powder management and powder removal station, an attachment ratio of 1:6. So they can support 6 printers. So only if you envision that kind of demand, you need to go with the full package solution. If not, you can just go with basic function, that is printer, curing station, and build unit. And now the question is, okay, now I've onboarded a program. Now it's ramping up. Now they like their parts and they want to give us an order for 500,000 or million parts. Do I need to add an extra printer? How does this process integration works? It's simple. You just need to add more bill units, more curing stations, and you add this powder management thing. Integration is very simple. It's not like you're starting from a smaller SKU, or you start with a smaller build SKU. You develop this process. Now you're going with a bigger platform. Or whether the process scales or not, it's not the problem. It's the same platform, same build area, same printing mechanism, same printer. It's just everything surrounding the printer, you're scaling it up. That's how it's made modular and scalable, and that will help you. And we can talk more about it depending on your needs. Some people may need only a printer, curing station, and only 1 bill unit or 3 bill units. Or what happens to your powder management, powder removal? I don't want to go with this expensive. Are there any alternatives from third party? We can definitely talk about that if you're interested. How does this work, right? Like if you look at it, this is a perfect scenario example which I took taken from our webinar series on costing. Scenario one, where you have a basic function, you're printing parts, you can look at $20 to $22 a part, just an example, it, and you're printing only bill right. Now the customer came and said, hey, I asked for 1,000 parts, now I want to make 10,000 parts. Now what you're doing is you're increasing the build height to 150, you're increasing the more number of bill units, more curing stations. You look at the cost per part is nearly half. 50% reduction, but the throughput has increased 5 times. If you're making 1,000 parts, now you can make 5,000 parts, just adding little bit of things around the printer. But the printer is the same, and printing speeds are the same. So with that, must have gone through at high level why Metal Jet can help you with creating this a complementary technology to your already existing manufacturing solutions, which you're serving the customers. Um, One thing mainly I would like to highlight before going to customer success stories is the way you're doing the business is not going to change. You're going to serve the customer instead of a plastic part, a lightweight part. You're going to serve a metal part, which is strong, and which is maybe like more expensive, or you're making more revenue on it. The business model will still remain the same. It's just that you're bringing a new technology. You'll be learning on the new technology, but you will be serving the customers with more options and and you'll be creating more revenue generating opportunities for your business. With that, like I said, I won't go through all the customer success stories. But if you would like to go deep dive on it on each of them, why this is suited for Metal Jet, why not other manufacturing technology, we would be happy to walk through you on that. But we have, like I said, we have global partners across the globe, and several customers have approached them, and we can only talk about things that we can share publicly. But there are several other things which we are not open to sharing publicly, but our contract manufacturers are making those parts for our OEMs and several end customers. What are the conditions suited for metal 3D printing? Like I said, right, I'll walk through this at a high level. If you want to have a deep dive, we can definitely go through it. In general, in medical tools and instruments, implants are good. Like, if for testing right now on implants, it's stainless steel. If it's made out of stainless steel, it's a perfect. We are a good technology to make it. Industrial fluidics, filters, and several tooling. Tooling is a very good case. What we are learning right now, if you're thinking about metal injection molding tooling or die casting tooling or plastic injection mold tooling, I think our technology can enable that with higher throughput and cheaper costs compared to the other alternatives in 3D printing. And consumer goods like sporting, fashion and jewelry, smart devices, and data centers. If you're talking about electrification, heat exchangers, pretty good technology that can make parts at high throughput and economical to the customer. And automotive, obviously, powertrain, styling, and things, right? And there are various high mix, low volume, supply chain optimization. If you're making a part through 3 different suppliers, it can be made through only one supplier. And obviously, performance enhancement through lightweighting and efficiency gains. So this is one of the applications case story. Sorry, if, I think the screen got cut down, but this is a Cobra Puma Golf putter head, which we launched in somewhere around 2020, and we've been working with them on a roadmap. This is done through Parmatech back then. What I would like to highlight is the design here. If you look at a traditional putter, it doesn't look like that. But this putter looks lightweighting. There's aesthetics of it looks pretty good for golfer, and also there is a performance gain. Using this lightweighting, they're changing the moment of inertia. So when your golfer puts a ball, they will have more feel, good sound, which is all important for a golfer, right? And what I can say, there are several tens of designs that have been iterated over the 6 months. which may not be possible if you're thinking of a tooling solution of making through forging and other things, because you need to make tooling for every time you want to change the design. And it enables this product. And this product was launched in 2020, probably in September timeframe, I believe. And they were expecting to sell all the 1,000 putters in a week or so. They got sold out in a day. So it's a huge business for Cobra as well. They saw the market is pulling it in, and they were able to get the products in time by reducing, since 3D printing is no toolless manufacturing, and the lead times they can are very low, so that they can deliver the parts to their final customers in no time. Second is, like I said, right, these are Indomem tools. Indomem right now is making their tools for their metal injection molding, but also serving the customers depending on their needs. Again, look at the variation. You can make a tool from 90 grams all the way to 2 kilos, and there are several performance benefits. Your cycle time, since this is made in M2, the wear resistance is significantly better. That improves your tool life. So there's no downtime on your injection molding, and you're amortizing more and more, so you can offer those benefits to your final customers. And again, these parts are massive parts with conformal cooling channels in them, and a technology can enable that. So, and this is among all the applications, this could be a lower hanging application that you can serve with to the customer, because of the validation that is required at the customer end. This is a very quick validation and high revenue generating opportunity. Then the third is, oh, I have this application, but it requires a little bit of class A1, class A2, mirror-like finish polishing and stuff. So this example though shows that, one of our contract manufacturer in Italy, Lego, has made several, is into fashion and jewelry and other industries. They make parts for several fashion and jewelry customers, and that are like, polished to perfection. And again, a lot of personalization and customization can be done, and that will create a more added benefit to your the customers. Finally, okay, then I would like to, okay, I'm talking about tooling, I'm talking about putter rates, but what are the performance enhancement applications? We just put demonstratory here. Like I said, right, we cannot publicly talk about applications because people are worried about IPs. But this gives you a very good overview through GK, and I've created this demonstrator for nozzles and mixers, how like see those lattices integrated inside the structure where they can mix the fluid, and you can route the optimally route the fluid. So these are all possible with 3D printing if you have some uh, design knowledge, design experience that you're already serving this customer. This is an value added benefit to you. So you already have the knowledge. Now you're just serving them through metals, and this is a knowledge that is not broadly available across the industry. And if you really have that knowledge, I think you're creating more value proposition to your business. Finally, this is a manifold, hydraulic manifold, like I said, right? Again, this mostly to showcase, hey, the part made with binder jetting can be weak or it's not great, but you can see they're successfully tested to 100 megapascals. These are servo manifold, and this is done by one of our contract manufacturer in Asia Pacific. And they ramped up very quickly. Within the 1 month of acquiring the printer, they started making these parts for their end customers and getting the orders and delivering to those orders. So the if you are familiar with the different kinds of powders, if you're familiar with 3D printing in general, not just binder jetting, I think you can ramp up very quickly and you can serve the needs of the final end customers. With that, thank you again for attending the webinar. I know we covered through at a very high level on a lot of the topics, but if you're interested in knowing more about the technology, if you would like to talk about your applications, if you would like to talk about how our technology fits your business needs, please don't hesitate to contact us. And with that, Zach.
Great. Thank you, Harish. That was perfect. I appreciate the information. Everybody, it looks like we are at our 30 minutes. So if you submitted questions, we'll get them answered for you via email. We will send out the replay of this webinar, as well as a link to all of our other great sessions via email within the next few days. And also keep an eye out for the Beyond the Forge session 11 topic announcement. So thanks to everyone for attending. A special thanks to Harish for presenting, and have a great rest of your day, everyone. Thank you.
Thank you.